Hello everyone, we're going to talk about sleeping or argon as well as battery conservation considerations. So one of the reasons that this is important is you might have many of these devices in some product that you're building, and you could have thousands of these. They could be in vehicles, let's say your UPS trucks, or they could be out in fields, in farmland, and you're measuring soil samples, or you're doing ecological work and research, and they're out in maybe a forest where there's animals, and they're measuring sound, vibrations, or number of animals in a certain spot, or weather, or whatever it might be. But you would have a ton of these devices, and obviously most of them probably don't have electricity. And so your goal is to keep them running as long as possible, because when they run out of power, you have to physically go find all these devices and charge the battery or replace the battery or something like that. So in this kind of scale, with devices that aren't plugged into power, and you really want to maximize how long you can go from recharges, it's really important to think about battery usage and power consumption. So power conservation is a pretty critical consideration in designing devices. So if you think about running your Argon or any microcontroller or laptop or phone, just running it constantly, it's running the loop code over and over again. So it's always on, very, very fast. It's also always connected to Wi-Fi, which is, or cellular if you're using that kind of a device, and it's connected to the particle cloud. It's also responding to any inputs or signals, right? So even if you're plugged into power, you could consider putting the device to sleep to save energy, which is important. If you're on battery power, then it's even more critical to use something like sleep to save battery life. And what sleep does is it's an operation in Argon, but also in lots of other devices and microcontrollers, just like with your phone or laptop, where it kind of powers down some of the components, but it's not quite like fully turning off. One point to note here, this is just recommended by the guidelines from Particle, which is that if you're going to sleep your device, do it for more than 10 seconds. If you're going to do it for less than 10 seconds, you're actually better off leaving it on, because there's a certain amount of energy and battery drain that happens in turning on, turning off. And so if you turn it on and off every 5 seconds, you're going to be wasting power. So Particle has 3 modes for the Argon: stop, ultra low power, and hibernate. From most of our considerations, stop and ultra low power are effectively the same. So we're going to be just looking at ultra low power and hibernate. So when you decide what sleep mode to go into, there's some special considerations you should make. And by the way, these kinds of questions, they apply to microcontroller design, but they also apply to essentially any kind of device you're building. These are similar types of things you'd have to think about. So you might want to consider, how do you plan to wake the device up, right? Do you want to wake it up over the internet? Do you want to have a button press, a time, at 5 p.m.? How do you need to turn on? How long do you want it to wait in between those periods? Right? How quickly should it respond? Is it okay if it takes 30 seconds when it turns back on? Or does it have to be just a couple of seconds? Like, what's your consideration? So in general, once you kind of think about these questions, you want to choose a power mode that uses the least power, but still feature the specific cases that you have. So one thing that Particle kind of points here is, this is a graph from their documentation. They're just pointing out that obviously on the far left over here, if you never turn the device off, you're using the most power, but you can publish messages to the clouds really quickly. Versus, if you're hibernating, you're almost powered down fully, then the time it takes to turn the device on and publish a message takes a long time. Right? Now, we're not necessarily doing cellular devices, so that's kind of an intermediate stage if your device has a cellular connection. But you can kind of see that this is a consideration of what are you effectively looking for in responsiveness versus power use. So of the 2 modes I talked about, hibernate and low power, these are how you can wake it up. So hibernate, for example, can only be woken up by an input signal, which would be kind of like a button press, or a specific time. So I would like to sleep for 30 seconds, or I would like to sleep for an hour. You can have it wake up. Okay, so kind of limited. Ultra low power actually has a lot of options. You can have it wake up when there's an input signal like a button press. You can have it wake up after a certain time. You can have it wake up to a specific analog voltage. So for example, if you want it to wake up at when you have a potentiometer, it gets halfway to 1.67 volts. You can set it up to do that. You can use a serial input. You can use our serial monitor and serial signals. You can have a Bluetooth connection, like a Bluetooth can trigger it. Or you can actually have a Wi-Fi connection, meaning you get something sent to you over the internet. So you can kind of see that this low power mode has a lot of options, but does use more power than Hibernate. So again, depending on what you're looking for is a consideration. Another consideration here is what happens when the code is running. So for example, in the case of Hibernate, you can see that actually it's as though the device were reset. So every time you run the code and you hibernate it, it's kind of like when it wakes back up, it runs reset, which means if you look kind of down here, you're going to lose your local variables. Maybe that's a concern, maybe it's not, but that's something you'd have to think about. Versus low power, which is almost like a pause. It's almost like a delay. You're basically just stopping your code, hence the stop, going to sleep, and waking up and coming back at that same line of execution, wherever you were. So you can see your local variables and your global variables are all preserved, which is nice. Now, one other option is it's possible that you can wake up but not connect to the internet. So this is a feature that exists in the Argon, which is you can go into a special mode where you turn on, but you don't connect to the internet. And so this is really useful if, let's say, you have a device that's out in the field and you want to preserve battery life as much as possible, and you don't need real-time data. You just need to basically collect data over the course of a day, and at the end of the day, send all that data to the cloud to storage, right? So in that case, what you could basically do is go to sleep. Wake up after an hour, half hour, whatever it is you need, but don't connect to the cloud. And how you do that, we'll talk about in just a second. You would then store your sensor value, take a temperature sensor, whatever it is you need, and then go back to sleep. And you could basically just continue this cycle for 24 hours or however long you needed to. And then at some point, when you reach capacity of storage or just a certain length of time, you wake up and then you connect to the internet and send the data as one big package. And the advantage of this is that you're saving time and you're saving battery life by not having to worry about connecting to the cloud and using the Wi-Fi antenna. So how you would do that, just for you if you're curious, is at the top of your code, you could say system mode semi-automatic. And that means when you boot up, do not connect to the cloud. And then at some point later, when you need to, you can say particle.connect, and that would connect to the cloud. So just a little bit of flexibility if you need that.